Hello, in this video I want to answer one question. What is knyte space? And I will use only knyte space to answer this question. So I want to prove you that knyte space is a self-explaining system. Knyte space is an implementation of semantic web. And it's not a simple implementation of idea of Tim Berners-Lee stated in 27. It's a different implementation that was formalized in 2012 by me. This semantic web is powered by homogeneous recursive semantic graph. This is the main idea. To understand knyte space, to understand this particular implementation of semantic web concept, came to us from Tim Berners-Lee. In 27. We should understand concept of homogeneous recursive semantic graph. Came in 2012 from me. Maybe some another person invented this system as well, this concept as well. But I don't know. If you already made it before me, please write me, we can discuss. So what is homogeneous recursive semantic graph? What is semantics? Semantics, it's operating with semantic entities. You can see I am creating entities. All these entities are semantic. Semantic entity has two sides. This is like side 1 and this is side 2. From side 1, this entity have some content, some human readable information. For example, it's saying I am entity number 1. So this is side 1, it's human readable. And this is exactly this. We can even describe like this: content equals this string. And side 2, it's machine readable. And what can machine say about this entity, this ID? This is globally unique identifier. This is a machine readable part, and it can be used in any algorithms, in any computations, any search and determination, definitions, mathematical definitions, logical definitions. Oh, this is useful for automated processing, and this is useful for human interpretation, human processing. So this semantic graph contains semantic entities that are friendly both for humans and for computers. So we can say that we explained what is semantic. Also, we should explain other aspects. For example, what is graph? Most of us know graphs from mathematics. This is A, this is B, and this is link between them. And this is very simple directed mathematical graph. And we also use this concept but improved. It's not mathematical graph, it's homogeneous recursive semantic graph. But mathematical graph is the basis, it's most simple implementation of idea of graph, and we use only directed implementation. And I will explain two other words, homogeneous and recursive, to let you understand the difference between our semantic graph and classic mathematical graph. So, third aspect, homogeneous. What is it? It means when you create entities, any of these entities can be node and can be link. So we have nodes, node 1, node 2 and link. Now it's not link, now it's also node, but we can convert it to link in a very simple way. And also we can convert it to another node, like this. We can link them by another entity. And semantics of this node or this entity didn't change. So if you make it link or make it pure node or even make it mixed node and link, its semantics doesn't change. It has the same identifier. So global unique identifier, the same. Doesn't matter how you treat it. Like this. It means homogeneous. Because all your entities in this graph have similar functionality. They are all similar. And for recursive, because of homogeneous, we can make it recursive. We can make links not only between two nodes, but also between node and link, and between link and link. It gives you very big flexibility for describing very complicated topics, very complicated objects. You can make semantic modeling using this recursive ability of the graph. And it's very useful for modeling of any data types and modeling of algorithms. Also, it's useful for modeling natural language sentences, and you will see how we can do it in another videos, more detailed videos. Oh, you can't make this structure in classical math graph, but you can make it in our recursive graph. So, in short, I answered question, what is knyte space?